Recall finds more. Precision keeps the right things. GraphRAG can win recall and still lose the answer. The paper reports GraphRAG retrieved 84% of the facts and still answered worse. MemGraphRAG names 3 construction failures behind the collapse. So I ran a small audit. The paper names the failure modes exactly, 3 of them, and they all trace back to the same root cause. Graph construction happens chunk by chunk, in isolation, with no global context shared across extractions. Each chunk produces its own triples without knowing what the rest of the corpus has already established. The graph grows. The signal-to-noise ratio collapses. The first failure mode is thematic irrelevance. Without knowing the corpus's core topic, extraction pulls in off-topic nodes. They get connected. The graph fills up with content that has nothing to do with why you built it. The second is logical inconsistency. 3 specific types, mutually exclusive facts, claims that can't both be true about the same entity. Temporal conflicts, facts that were true at some point but have no timestamp. So old and current coexist as if both are valid right now. And granularity conflicts. The same entity described at wildly different abstraction levels across chunks, with no coreference to unify them. The third is structural fragmentation. Key entities scattered across disconnected subgraphs. Without global coreference resolution, multi-hop traversal breaks. The graph physically cannot connect what it needs to retrieve. MemGraphRAG fixes this with 2 structures working in parallel, 3 hierarchical memory layers, and 3 specialized agents that govern every extraction in real time. The memory lives on 3 shelves. The ontology layer holds schemas and patterns like person, born in, country, and tracks how often each schema appears across the entire corpus. A schema only becomes stable when it crosses a frequency threshold. Below that threshold, any triple that matches it stays in a pending state. It does not enter the graph. The fact layer holds concrete triples, but only those anchored to stable schemas. Every fact here knows which schema governs it and can be traced back to its source. The passage layer is the evidence vault. Every fact links back to the original text passage it came from. This is what makes conflict resolution possible. When 2 facts contradict each other, the agent can compare the actual source passages to decide which one wins. 3 agents work this memory in real time. The extraction agent writes to all 3 layers simultaneously, not dumping raw triples, but aligning each one to a schema and grounding it to a source passage. The conflict detection agent monitors the fact layer asynchronously, flagging any pair of facts that contradict each other, and the resolution agent adjudicates using evidence. It retrieves the supporting passages for both sides of the conflict, compares the textual support, then filters the invalid fact, merges the redundant pair, or temporally bounds the conflict. So I ran a simple failure mode audit against a real knowledge base, not a benchmark reproduction. A practical audit on the MSG encrypted wiki, the production workspace my AI agents use for context. I checked all 3 failure modes. First, thematic irrelevance. I found raw trend notes where off-topic videos sit beside active agent memory results. Fine as raw data, dangerous if retrieval treats every row as current evidence. Second, logical inconsistency. Older files frame the account around Starknet, AFK, and crypto principles moving into AI. The current brand source says AI developer engineer, hypothesis to test to result, with cypherpunk values as the ethical frame, not the headline. Without recency or source priority, both can look equally current. Third, structural fragmentation. The same memory loop idea appears under agent memory governance, workspace brain, G-brain audit, Graphify plus G-brain, and MemGraphRAG governance. Multi-hop retrieval has to guess that these are connected. In under an hour, the audit surfaced examples of all 3 failure modes, not because the wiki is poorly maintained, but because isolated extraction almost always leaves these fingerprints. If your agent has been ingesting documents for more than a few weeks, you should check for all 3. The takeaway is simple. Bad GraphRAG is usually not a retrieval problem. It is a graph construction problem. MemGraphRAG fixes that by governing what enters memory. Schemas stabilize first, facts attach to evidence, and conflicts get resolved before retrieval. The paper-reported benchmark is that cleaner graphs retrieve faster and answer better, 0.061 seconds per query, about 180 times faster than light RAG, with stronger generation accuracy across multiple benchmarks. For your own agent memory, audit 5 things: off-topic nodes, contradictory facts, fragmented aliases, missing source passages, and stale retrieval results. If you only remember one line, recall finds more, but governance keeps memory useful. Which failure mode do you think is already in your knowledge base? Thematic irrelevance, logical inconsistency,